Okay students, today discuss the topic Unit-8 Ionic Equilibrium. Ionic Equilibrium. This session I am going to teach acid-base concept theories, Arrhenius theory, Lowry-Bronsted theory and Lewis theory. Right? So first one is introduction of ionic equilibrium. We have already learned chemical equilibrium in 11th standard. In this unit, we discussed the ionic equilibrium, specifically acid bases equilibrium. Acid bases equilibrium. Okay. There are some of the important processes in our body involve aqueous equilibrium. நம்ம பாடியில நடக்கக்கூடிய நிறைய ப்ராப்பர்ட்டிஸ்ல இந்த aqueous equilibrium அப்படிங்கிறது ரொம்ப ரொம்ப இம்பார்ட்டன்ட். Some of the important processes in our body involve aqueous equilibrium. Aqueous means water contained solutions. For example, the carbonic acid H2CO3, the carbonic acid and bicarbonate ion, HCO3 minus is a bicarbonate ion, H2CO3 is a carbonic acid. The carbonic acid and bicarbonate buffer in the blood. The meaning of buffer, okay, a solution which resists, which resists in pH. When acids or alkali added, do it to it. அதாவது ஆசிட் பேஸ் ஆட் பண்ணாலும் அதோட pH மாறாம பாத்துக்கிறதுக்கு தான் பஃபர் சொல்யூஷன் அப்படின்னு பேரு. நம்ம பிளட்ல இருக்கக்கூடிய ஒரு பஃபர் சொல்யூஷன் கார்போனிக் ஆசிட் அண்ட் பைகார்பனேட் அயான் பார்ட்டிகல்ஸ். இதனுடைய ஈக்குலிபிரியத்தினால தான் பிளட்டோட pH சேஞ்ச் ஆகாம. இப்ப நம்ம நிறைய ஆசிட் இருக்க பொருள் பேஸ் இருக்க பொருள்லாம் சாப்பிடுறோம். அப்படி சாப்பிட்டாலும் பிளட்டினுடைய pH மாறாம இருக்கிறதுக்கு காரணம் இந்த கார்போனிக் ஆசிட் அண்ட் பைகார்பனேட் பஃபர். You right? So H3O plus aqueous solution, HCO3 minus bicarbonate ions, equilibrium, H2CO3 carbonic acid and water. You right? So H3O plus. இப்போ இதுல இருக்கக்கூடிய வாட்டர்ல ஆசிட் ஆட் பண்றீங்க அப்படின்னா அதுல இருக்கக்கூடிய H plus இதுல இருக்கக்கூடிய OH minus எடுத்துக்கிட்டு வாட்டரா மாறும். ஆசிட் ஆட் பண்றீங்க, பேஸ் ஆட் பண்றீங்க அப்படின்னா பேஸ் ஆட் பண்ணும்போது OH மைனஸ் H plus எடுத்துட்டு வாட்டரா போகும். ஆசிட் ஆடும்போது இது கூட ஆசிட் H plus ஆசிட் இது கூட ஆட் ஆகி கார்போனிக் ஆசிட் தான் மாறும். So ஆசிட் ஆட் பண்ணாலும் சரி பேஸ் ஆட் பண்ணாலும் சரி ஈக்குலிபிரியம் ஆகும், pH ல சேஞ்ச் இருக்கு. Are you right? So ஹைட்ராக்சைடு அயான்ஸ் இது கூட ஆட் ஆகி வாட்டரா மாறும். H plus எடுத்துட்டு ஆசிட் ஆகுனா H plus இது கூட ஆகும், ஏன்னா நெகட்டிவ். So H plus ஆட் ஆகி கார்போனிக் ஆசிட் மாறும், pH வேல்யூ சேஞ்ச் ஆகும். Are you right? So we have come across many chemical compounds in our daily life. Among them, acid and bases are most common. For example, milk, pulp, lactic acid. Milk contain lactic acid. Lactic acid formula CH3 CHOH bond COOH. CH3 bond CH bond OH bond COOH. Lactic acid. Milk contain lactic acid and vinegar contain acetic acid. CH3 COOH acetic acid. And tea contain tannic acids. The tannic acid molecular formula C76. The 76 carbon and 52 hydrogen. 76 carbon and 52 hydrogen and 46 oxygen. The molecular formula of tannic acid C76H52O46. The next one is antacid tablet. Acidity cure பண்ணக்கூடிய tablet, antacid tablet. So acid nature, so basic nature tablet, aluminum hydroxide and magnesium hydroxide. Aluminum hydroxide and magnesium hydroxide. Right? The acids and bases have many important industrial applications. For some example, sulfuric acid. H2SO4. Sulfuric acid. So used in fertilizers industries. So acid. The next one example, base. Sodium hydroxide. So sodium hydroxide used in soap industry. Already you know that saponification reaction. Okay, the basic hydrolysis of glyceryl ester. You right? So hence it is important to understand the properties of acids and bases. So acid base உடைய properties பத்தி தெரிஞ்சுக்கிறது ரொம்ப அவசியமானது, முக்கியமானது. So அத பத்தி தான் இந்த லெசன்ல நம்ம பார்ப்போம். Acids and bases. The term acid derived from the Latin word acidus. The Latin word acidus meaning sour. The taste in acid, sour taste. So புளிப்புச்சுவையுடைய. The acid turns blue litmus to red. Okay, so acids, the term acid derived from Latin word acidus meaning sour, புளிப்புச்சுவையுடையது. The acid turn blue litmus to red litmus. Blue to red. Okay, so the blue litmus change into red color. Similarly, the base bitter taste. கசப்பு சுவையுடையது. The red litmus turn to blue in base. You write acids reacts with metal to give hydrogen gas. For example, zinc reacts with hydrogen chloride, hydrochloric acid to give zinc chloride and hydrogen gas. Right? 2. This classical concepts are not adequate to explain the complete behavior of acid base. So scientists developed the acid base concept based on the behavior. Let us learn the concept developed by the scientists Lowry-Bronsted, Arrhenius, Lewis. So to describe the properties of acids and bases. To describe the acids and bases. The properties of acids and bases. Students, one of the earliest theories about acids and bases was proposed by the Swedish chemist Arrhenius. The Arrhenius concept, acid means an acid is a substance that dissociates to give hydrogen ions, H plus ions, dissociates to give hydrogen ions in water. Okay, so water la dissociate ஆகி H plus ions எது தருதோ அதுதான் acid அப்படின்னு சொல்றோம். Okay, for example, hydrochloric acid, sulfuric acid, H2SO4, acetic acid and etc. are acids. The dissociation in aqueous solution. Okay, Arrhenius So ஒரு acid base அப்படிங்கறத எதுல மட்டும் தான் explain பண்றாரு? An aqueous solution, water dissolving solution, expressed as. Are you right? An acid is a substance that dissociates to give hydrogen ions in water. Hydrogen ions in water. For example, HCl, hydrochloric acid. To dissociate with water to give H plus ions. Okay, so form H plus and Cl minus. The hydrochloric acid dissociated in water to give H plus and Cl minus. The H plus ions is a highly hydrated. H plus ion is a highly hydrated, usually represented as H3O plus hydronium ion. So right, the H plus water, HOH water. So right, say Lewis base H plus. To donate the lone pair of electron, convert H3O plus ion, hydronium. H plus ion is a highly hydrated, so and usually represented as hydronium ion, H3O plus. You write the simplest representation, the hydrated proton, H plus. The hydrated proton, H2O, hydrated protons. You right? Okay. Similarly, a basis is a substance that dissociates to give hydroxide ion. What ion? Hydroxide ions. OH minus ion in water. A base is a substance that dissociates to give hydroxide ions in water. Okay, so Arrhenius எல்லாமே aqueous solutionல தான் explain பண்றாரு. ஒரு ஆசிடா இருந்தா வாட்டர்ல H plus ions டொனேட் பண்ணனும். பேஸா இருந்தா ஹைட்ராக்சைடு ions டொனேட் பண்ணனும். For example, base sodium hydroxide, calcium hydroxide, potassium hydroxide. Okay, the calcium hydroxide dissociate in water, H2, dissociate in water to give hydroxide ion to OH minus. Okay, so dissociate to give H plus ion in water, dissociated to give hydroxide ion in water. Okay, so HCl in aqueous medium. HCl gas dissolved in water to give H plus in aqueous medium, Cl minus in aqueous medium, calcium 2 plus in aqueous medium, and OH minus in aqueous medium. So we use H plus and H3O plus are same in meaning. So meaning same. So ரெண்டுமே ஒரே மீனிங் தான். H plus யூஸ் பண்ணிக்கலாம், H3O plus யூஸ் பண்ணிக்கலாம். Right? Limitation of Arrhenius concepts. Limitations of Arrhenius concepts. The first one is the Arrhenius concept does not explain the behavior of acids and bases in non-aqueous solvents. Organic solvent. Non-aqueous solvent is an organic solvent such as acetone, CH3CO, CH3 acetone, and tetrahydrofuran. The structure of tetrahydrofuran, CH2, 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 CH2. This CH2 4 times O. Molecular formula is a cyclic structure. So organic solvent, right, does not explain the behavior of acids and bases in non-aqueous solvents such as acetone and tetrahydrofuran and etc. ஒரு ஆர்கானிக் சால்வெண்ட்ல ஆசிட் பேஸ் கான்செப்ட் பத்தி அவரு எந்த எக்ஸ்பிளனேஷனும் கிடையாது. ஒன்லி aqueous சொல்யூஷன்ல மட்டும்தான் H plus வச்சு H plus டொனேட் பண்ண ஆசிட் OH minus டொனேட் பண்ணா பேஸ் அப்படினு சொல்லி எக்ஸ்பிளைன் பண்ணார். Are you right? The first limitation. The second limitation does not account for the basicity of the substance like ammonia. So which does not possess hydroxide group. Okay, so ammonia is a base. Ammonia is a base, but cannot explain in Arrhenius concept. Okay, cannot explain in Arrhenius concept why the ammonia does not contain hydroxide. Ammonia does not contain hydroxide group. Right? So does not account for the basicity of the substance like ammonia. Ammonia is a basic substance but cannot explain in Arrhenius concept why that does not contain hydroxide group in ammonia. You right? The next theory, Lowry-Bronsted theory. So proton theory. In 1923, Lowry and Bronsted suggested a more definition in acid bases. More definition in acid bases. According to Lowry-Bronsted concept, the acid means a substance that has a tendency to donate a proton. A substance that has a tendency to donate a proton to another substance. So acid அப்படிங்கிறது proton H plus இன்னொரு சப்ஸ்டன்ஸ்க்கு டொனேட் பண்ணா அது acid அப்படினு சொல்றோம். According to Lowry-Bronsted theory, the base is a substance that has a tendency to accept a proton. Accept a proton from other substance. In other words, the acid is a proton donor. Acid is a proton donor. Acid is a proton donor. The base is a proton acceptor. So acid is a proton donor. Proton ஐ வழங்கக்கூடியது acid. The base is a proton acceptor. Proton accept பண்ணிக்கிட்டா base. In Arrhenius concept, acid donate H plus ions. Base accept the hydroxide ions. In Lowry-Bronsted concept, the proton donor acid, the proton acceptor base. Right? The example HCl, hydrochloric acid. The hydrochloric acid HCl dissolve in water. HCl dissolve in water. You write the HCl donate a H plus ion proton to the water. You write to convert Cl minus and H3O plus. So H plus proton donor acid. The proton acceptor base. Okay, so HCl act as a acid, the H2O act as a base. The proton transfer from acid to base. The proton transfer from acid to base represented as, you write the base, for example, ammonia, NH3. Ammonia dissolve in water, H2O, to give accept proton. Ammonia accept proton to convert NH4 plus ions, ammonium ions, NH4 plus ions and hydroxide OH minus ions. Okay, a substance that has the tendency to accept a proton from the other substance. Okay, so ammonia act as a base. Ammonia act as a base, H2 act as a acid. Right? So this one is the proton transfer from acid to base representation. This one is the proton accept proton from base to acid. The accept proton base to acid representation. Are you right, students? Let us consider the reverse reaction. Let us consider the reverse reaction in the following equilibrium reactions. Okay, so HCl is a proton donor. Proton donor, so act as a acid. H2O, proton acceptor. Proton acceptor act as a base. So H3O plus proton donor. Proton donor act as a acid. The Cl minus is a proton acceptor. Proton acceptor, so act as a base. The hydronium ion, the H3O plus, donate a proton to the Cl minus to give HCl. And water in the reverse reaction. The hydronium ion donate a proton to the chloride ion to give HCl and water. The product are also act as a acid and base. The product are also act as a acid and base. The proton donor acid, the proton acceptor base. In general, Lowry-Bronsted acid-base reaction is represented as acid 1, base 2, acid 2, base 1. The HCl is a acid 1. The HCl is a acid 1. In this reaction, the space that remains after the donation of a proton. The space remains, and after the donation of a proton is a base, is called conjugate base. Conjugate base. This base is base 1. This base is base 1. Are you right? The acid 1 HCl. Okay, the HCl donate a proton to the H2O, the remaining part Cl minus. The species remain after the donation of a proton. Proton is a base, is called conjugate base. Conjugate base, base 1. So acid 1 HCl, the base 1, conjugate base, proton acceptor, so base, conjugate base B1, base 1, right? So another one where the chemical pieces differ only in proton. In another word, the chemical pieces differ only in the proton. So HCl and Cl minus does not have H plus. HCl have H, hydrogen, H plus. Okay, the chemical pieces differ only. Proton is called conjugated acid-base pair. Conjugated acid-base pairs. So HCl and Cl minus is a conjugated acid-base pairs. Alright? and H2O, H3O plus. So extra one H plus ions are there. So options are extra H plus. So the chemical pieces are differ only in proton. So conjugated acid base pair H2O and H3O plus donate a protons. So proton donor act as a acid. Right? So acid 1, acid 2, acid 1, acid 2. Base 1 H2O is a base 2. Right? So acid 1 HCl and base 2 H2O, right? Acid 2 H3O plus and base 1 Cl minus. Okay, so the remains after the donation of proton is a base. It's a conjugated base. It's a base 1. Base 1. So donate proton donor acid 1. Proton donor acid 1. Are you right? The proton acceptor base 2. Base 2. Proton acceptor base 2. Are you right? So H3O plus is acid 2. Acid 2. Okay. So in other words, the chemical phases differ only proton is called conjugated acid base pairs. The HCl and Cl minus, HCl and Cl minus is a conjugated acid base pair. In another one pair, H3O plus and H2O is a conjugated acid base pair. Okay, so conjugated HCl and Cl minus is a conjugated acid base pair, and H2O and H3O plus are also conjugated acid base pair. Okay, so HCl is a conjugated acid. Okay, students, the HCl is a conjugated acid of a Cl minus. Conjugated acids of a Cl minus. Cl minus is a conjugated base of a HCl. Are you right? So HCl, Cl minus nuடைய conjugate acid, Cl minus HCl nuடைய conjugate base. Similarly, H2O is a conjugate base of the H3O acid. The H3O is a conjugated acid of the H2O base. Are you right? So in the H2O, the H3O plus inuடைய conjugate base act பண்ணும். In the H3O plus, in the H2O inuடைய conjugated acid ஆ இருக்கும். So இதுதான் conjugated acid base pairs அப்படினு. ஓகேவா? So இது acid, அதனால இதுக்கு இது conjugate acid ஆ இருக்கும். இது base, இதுக்கு இது conjugated base ஆ இருக்கும். Limitations of Lowry-Bronsted theory. Limitations of Lowry-Bronsted theory. This theory cannot explain the acid behavior of boron trifluoride and aluminum chloride and etc. So BF3 and aluminum chloride are also act as an acid but cannot explain in this theory. Why? The BF3 boron trifluoride and aluminum chloride does not contain proton H plus ion. So does not contain H plus ion, proton. According to Lowry-Bronsted theory, the proton donor is an acid, the proton acceptor is a base. But BF3 and aluminum chloride does not contain H plus ion, so cannot explain the acid behavior of boron trifluoride and aluminum chloride. Okay, students, the third concept, Lewis concept. The third concept is Lewis concept. In 1923, The Lewis proposed a more generalized acid-base concept. This concept used in all compounds, maximum used in all compounds. Right? He considered the electron pair. Consider the electron pair to define a species as an acid or a base. Acids or a base. In a Lowry-Bronsted concept is a proton concept. Lewis concept is a electron pair concept. Electron pair concept. According to Lewis concept, the acid defined as an acid is a species that accepts on electron pairs. So accepts on electron pair is a acid. The donates on electron pairs is a base. An acid is a species that accepts an electron pair. And base is a species that donates on electron pairs. So electron pair accept panna acid, electron pair donate pannichuna adu base. So Lewis acid and Lewis base. The Lewis acids in a positive ions. Positive ions Fe3 plus, Cu2 plus. Right? So positive ions contain vacant orbital. Iron and copper contain vacant d orbitals. So accept an electron pair in vacant orbital. So positive ions are electron deficient pieces. Electron deficient. The electron deficient atom. Electron deficient atom or molecule. Electron deficient molecules. Electron deficient molecules. For example, boron trifluoride. Boron trifluoride. Boron B. Okay, F. 2, 4, 6. Only 6 valence electrons are available. Do not obey octet rule. So obey octet rule to accept more than 2 electrons. So one lone pair of electron to accept in this boron atom. So electron deficient molecules. Electron deficient molecules. In Lewis base is an anion. Lewis base is an anion. F minus, Cl minus, SO4 2 minus. So electron pair donor or the neutral molecules. At least one lone pair of electron contain neutral molecules. For example, ammonia NH3, nitrogen 7, 2, 5. The 5 valence electron in nitrogen 1, 2, 3, 4, 5. The non-bonding electron. So ammonia contain one lone pair of electron. You write? So anion or neutral lone pair of electron contain molecules or act as a Lewis base. For example, the boron trifluoride. Boron trifluoride reacts with ammonia NH3. Boron trifluoride reacts with ammonia. The boron, atomic number boron 5. Electronic configuration 1s2, 2s2, 2p1, 2p1. Okay, the outermost orbital 2s2, 2s2 and 2p1. So 2p1. In excited state, the electron transfer from s orbital to p orbital. So 3 lone pair of electron. 3 lone pair of electron. Thus 3 lone pair of electron. Boron B. Okay, having 3 lone pair of electron. 3 lone pair of electron and 3 lone pair of electron and one vacant p orbital. One vacant p orbital. So electron deficient pieces. Electron deficient pieces. The each unpaired electron covalent bonded with fluorine atom. Fluorine. So BF3. BF3 contain one vacant orbital. So electron acceptor. Electron acceptor. Electron pair acceptor. Electron pair acceptor. Chloride plus ammonia reacts with ammonia. So ammonia, nitrogen N. Nitrogen N. Atomic number 7. 2,5. 2,5. So nitrogen. Valence electron 1, 2, 3, 4, 5 electron. The 3 electron combined with the hydrogen atom. Okay, so nitrogen contain one lone pair of electron. The lone pair of electron contain neutral atom, act as a Lewis base. So electron pair donor. Electron pair donor. You right? So electron pair acceptor act as a Lewis acid. The electron pair donor Lewis base. Lewis base. The nitrogen donate the lone pair of electron to boron atom. Donate the boron vacant accept the boron in lone pair of electron in vacant orbital to form the coordinate covalent bond. The adduct BF3 NH3 adduct is formed. The adduct is formed. The new coordinate covalent bond is formed. The coordinate covalent bond. Coordinate covalent bond is formed. Okay, so BF3 electron pair acceptor act as a Lewis acid. In ammonia, so electron pair donors act as a Lewis base. Okay, already you know that in coordination compound. Example. Tetraamine copper 2 ion. That the structure of coordination compound, the copper 2 plus. Okay, the positive ions act as a Lewis acid and NH3. The all nitrogen contain one lone pair of electron. That lone pair of electron donate the central metal atom. So central metal atom act as a Lewis acid. The ligands act as a Lewis base. Okay, so electron donor Lewis base. All ligands are act as a Lewis base. The all central metal ion act as a Lewis acid. The difference between Lewis acid and Lewis base. The difference between Lewis acid and Lewis base. The Lewis acid, the electron deficient molecules. The Lewis acid is a electron deficient molecules. Example: boron trifluoride, aluminum chloride, beryllium difluoride. So boron trifluoride. Already you know that boron atomic number 5. 1s2, 2s2 and 2p1. Okay, valence electron. So 2 and 3. So 2s2, 2p1. In excited state, the 2s electron is transferred from 2p orbitals. You write the 3 unpaired electron combined with the 3 fluorine atom. 3 fluorine atom. One vacant orbital is available in BF3. So electron deficient molecules. Aluminum chloride AlCl3. Aluminum atomic number 13. So 1s2, 2s2, 2p6, 3s2, 3p1. So 3s2, 3p1. So 3s and 3p. 3s and 3p. Alright? In excited state, the s electron is transferred from 3p orbital. So 3 unpaired electron combined with 3 chlorine atom. 3 chlorine atom. So 1 vacant orbital is available. The electron deficient molecules. Beryllium difluoride, beryllium, atomic number 4, 1s2, 2s2, the outermost orbital 2s2, 2p0, so 2s2, 2p, 2s2 and 2p0. In excited state, the 2s electron transfer from higher 2p orbitals. Okay, so the 2 unpaired electron reacts with 2 fluorine atom to form beryllium fluoride. The 2 vacant orbital is available in 2p orbital in beryllium. Right? So electron deficient molecules so act as a Lewis acids. Then Lewis base, the molecules with 1 or more lone pair of electrons. The molecules with 1 or more lone pair of electron. So nitrogen, already you know that nitrogen atomic number 7, 2, 5. The 1, 2, 3, 4, 5. 5 valence electrons are there. The 3 valence electron combined with the 3 hydrogen atom. So 1 lone pair of electron is available in nitrogen. You right? So the lone pair of electron donate the electron deficient species. So act as a Lewis base. Okay. So water HOH. Oxygen. Outermost 6 electron. 1, 2, 3, 4, 5, 6. 2 lone pair of electron available in oxygen atom. So act as a Lewis base. So alcohol, oxygen, 2 lone pair of electron, either oxygen 2 lone pair of electron, nitrogen 1 lone pair of electron in amine. Okay, so all the compounds act as a Lewis base to donate the lone pair of electron to electron deficient species. Are you right? So second point, all metal ions are atoms. All metal ions are atoms. Okay, so iron 2 plus, Fe3 plus, chromium 3 plus, the chromium 24. The valence electronic configuration 3d5 4s 1. The valence electronic configuration of chromium 3d5 4s 1. Right? So 3d orbital 1, 2, 3, 5 and 4s 5 electron 1, 2, 3, 4, 5 and 1 4s orbital. Chromium 3 plus, loss of 3 electron 1, 2, 3 electrons. The vacant d orbital is available in chromium 3 plus. So vacant orbital available. Metals act as a Lewis acid. Right? So all metals act as a central metal ion. Okay, Fe2 plus, Fe3 plus, Cr3 plus, Cu2 plus is a central metal ion in coordination compound. So central metal ions act as a Lewis acids. So all anions, F minus, Cl minus, Cn minus, Cn minus, SO2 minus. So contain lone pair of electron, non-bonding electrons to donate the electron deficient species to act as a Lewis base. For example, HC double bond OH. Formic acid reacts with fluorine F minus. The F minus give the electron to the carbon O minus. Okay, so HCO minus FOH. The F minus donate the electron pair to carbon act as a Lewis base. Lewis base. The carbon act as a Lewis acid. Acceptor, donor. Right? The third one is the molecules contain polar double bond. The molecules contain polar double bond. SO2, SO3 and CO2. For example, CO2. The Lewis structure of CO2. Carbon, CO2. So, 4 valence electron in carbon. Each oxygen 6, 12. So, totally 16 electrons. The one of the Lewis structure of carbon C, O, okay, 2, 4, 6, 8, 12. Not at all. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14, 16. 16 valence electrons. Right? But cannot obey in octet rule in carbon, so the electron transfer from this place. Are you right? So O bond C, double bond O, double bond O, the polar double bond. That bond having polar double bond. Are you right? So the formal charge of oxygen 0. The formal charge of carbon plus the formal charge of oxygen minus 1. The formal charge calculation formula, valence electron minus lone pair of electron minus bond pair of electron by 2. In a valence electron 2, 4, 6. So valence electron oxygen 6. The lone pair of electron 6 minus bond pair electron 2 by 2. 1. 6 minus 7 is equal to minus 1. Minus charge. The formal charge of carbon. The formal charge of carbon C plus. Okay. So valence 4. Carbon valency 4. Okay. Minus lone pair of electron 0. No lone pair of electron. Bond pair electron 2, 4, 6. Minus 6 by 2 by 4 minus 0 minus 6 by 2 3. So 6 by 2 3. Now 4 minus 3 is equal to plus 1. The formal charge of carbon plus 1, oxygen minus 1 reacts with water H2O. The H2O contains lone pair of electron. That lone pair of electron donate to carbon plus to form carbonic acid H2CO3. H2CO3. So electron donor is a Lewis base. Electron acceptor Lewis acid. Okay. So sulfur dioxide SO. Sulfur. Valence electron 6 plus 6 plus 6 12. So 18 electrons. Valence electron 18 electrons, right? So 2, 4, 6, 2, 4, 6. Okay, 2, 4, 6, 2, 4, 6, 8, 10, 12, 14, 16. Remaining 2 electrons. Okay, so available in only 2, 4, 6 electrons. Okay, so obey octet rule, 2 more electrons is available. Okay, so reacts with the water H2O. The O donate the 2 electron. Okay, to form H2SO3. Sulfurous acid. H2SO3. Right? In SO3, sulfuric acid, sulfur. O. 1 oxygen and 1 sulfur, 6 valence electron. Each oxygen having 6 valence electron. 6 into 3. 18. So 18 plus 12, 24. 24. So 2, 4, 6. 2, 4, 6, 8. Octet rule. 2, 4, 6. Octet rule. 2, 4, 6, 8. Octet rule. So how many electron? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Right? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So only 6 electron in valence cell. You right? So cannot obey octet rule. So accept 2 electron in water. So electron donor Lewis base, electron acceptor Lewis acid to form sulfuric acid H2SO4. You right? Lewis base, the carbon-carbon multiple bond having molecules act as a Lewis base. So one bond is a sigma bond, another one bond is a pi bond. One sigma bond, 2 pi bond. The pi bond is a weak bond, easily donate the other molecules. So electron pair donor is a Lewis base. 2 points. Molecules in which the central atom can expand its octet due to the availability of empty d orbitals. Availability of empty d orbitals. The molecules in which the central atom can expand. The central atom can expand its octet due to the availability of empty d orbitals. Availability of empty d orbitals. Example: sulfur. Okay, silicon tetrafluoride, sulfur tetrafluoride, ferric chloride. For example, sulfur 16. The outermost orbital, valence orbital, contain 3s2, 3p4. 3s2, 3p4, 3s. 3s2, 3p4. 1, 2, 3, 4. In ground state electronic configuration. In excited state, the sulfur reacts with fluorine. So 3p and 3d orbital. 1, 2, 3. 1, 2, 3, 4. 5. In excited state, the p orbital transfer from 3d orbitals. The molecules in which the central atom sulfur can expand its octet. 3s2, 3p4 in excited state. Okay, the 4 fluorine combined with the 4 unpaired electron. 1, 2, 3, 4. So obey the octet rule. 2, 4, 6, 8. The molecules in which the central atom can expand its octet. Octet 2. So sulfur. F. 1 lone pair of electron. 1 lone pair of 2, 4, 6, 8. 2, 4, 6, 8. Okay, extend the lone pair of electron due to the availability of empty d orbitals. Availability of empty d orbitals. Okay, so empty d orbitals contain molecules act as a Lewis acid. The Lewis base, all metal oxides, calcium oxide, magnesium oxide and sodium oxide. For example, calcium oxide reacts with carbon dioxide. So carbon dioxide acts as a Lewis acid. Polar bond having molecules. Okay, so the lone pair of electron donate the carbon dioxide to form calcium carbonate. Calcium carbonate. So act as a Lewis base. The fifth one is carbanion. So carbonium ion, carbocation act as a Lewis acid. So reacts with the hydroxide ion. So Lewis base, Lewis acid to form alcohol. To form alcohol. Tertiary butyl alcohol. Tertiary butyl alcohol. CH3C, CH3, CH3. Donate the OH minus ion. OH. Electron donor Lewis base. Electron acceptor Lewis acid. Carbanion. Carbanion. So reacts with the H plus ion to donate the electron to the H plus ion to form methane. electron donor, electron pair donor, Lewis base. So positive ions, Lewis acid. You right? So according to Arrhenius theory, the acid means the dissociate to give H plus ion in water. Base dissociated give hydroxide ion in water. Okay, so according to Lowry-Bronsted concept, proton concept, the proton donor acid, the proton acceptor base. In Lewis acid base concept, the electron pair acceptor, lone pair of electron acceptor, the electron pair acceptor acid, the electron pair donor base. Okay, thank you students, we'll meet next class.